Hello everyone, welcome back to LMJ, and today I'll be discussing the best maths question from Allen AIOT. So I have taken 4 best questions from one paper of Allen AIOT, and they are very good questions. And let me know if this is helpful and you need from any other test series also. So don't forget to like and subscribe. So let us begin with the first question. The first question is a very good question and it is relating trigonometry, vectors, and summation. So let us see. So if the sum of this summation arc sine is equal to 2n minus 1 pi by lambda, where n belongs to natural numbers and n is greater than equal to 2, then lambda is equal to. So first we look at this expression. This is a very big expression, so don't get scared. This obviously has something to do with angles because there is an arc sine here outside the bracket, so this must be related to an angle. And this looks like magnitude of two vectors, and this looks like the dot product of these two vectors, right? So let us start by defining two vectors. Let us start by defining a general vector. So take vector vi. N is a constant here and I is something that we will be summing over for I is equal to 0 to I is equal to n. So the angle which I am denoting by theta I plus 1 between vi and vi plus 1 we can take the cos of this angle. It will be given by the dot product formula, which is I am doing this because this thing resembles this thing, right? So it will be which is exactly the expression which is inside the bracket of the question. So let me denote this as P because I don't want to write this again and again. So theta I plus 1 can be given as arc sine of P, right? So let us see what this actually means. So we are summing from 0 to n minus 1, right? So theta I plus 1 is the angle between vi and vi plus 1. So if we take I is equal to 0, then we will get theta 1, which means that if we take v0 here and v1 here, so this is theta 1, right? Similarly, this is theta 2. And if we continue this, then we will get vn minus 1 here and vn here. So this will be theta n. So we need to find the summation of these angles till vn, right? And we know that vn has the coordinates as n comma n. So this implies that x is equal to y, and whenever we have x is equal to y, then the angle is 45 from the x-axis. So this means that this whole angle should be equal to 45 degrees, right? So this means that this should be equal to 45 degrees. Okay, so summation of I 0 to n minus 1 arc sine of that expression is 45 degrees. But in the question we are asked for, sorry, this would be arc cos, right? I wrote sine by mistake. Here we have arc cos, but we are asked for arc sine, and we know one relation that arc sine of x is equal to pi by 2 minus of arc cos of x. So we will get that arc sine of that expression is equal to pi by 2 minus arc cos of that expression, which is pi by 2 minus of theta I plus 1. So we will get that if we sum on both LHS and RHS from I is equal to 0 to n minus 1, arc sine p is equal to, we have to sum this also from I is equal to 0 to n minus 1 minus, so this will become equal to from 0 to n minus 1 there are n terms, right? So this will be n pi by 2 minus this we already derived as pi by 4. So we will get, which is equal to 2n minus 1 pi by 4, right? And this was that expression that was in the question, and this was given equal to 2n minus 1 pi by lambda. So comparing these two, we will get lambda is equal to 4. So this was a very nice question where you had to think in terms of vector, and you had to see that this is resembling the formula of dot product by their magnitudes. So let us move on to the second question. So this is from the chapter arithmetic progression. So this says that if the nth term of an arithmetic progression is Tn equals a minus 3n cube plus b minus 4n square plus a plus b multiplied by n minus 4 for all n belonging to natural number, then which of the following is true? Okay, so we need to remember that if the Tn is representing a term of arithmetic progression, then it can only depend on n, and it cannot depend on any higher order of n like n square or n cube. I can prove this. So Tn plus 1 minus Tn gives us the difference, which is a constant, right? Because difference of terms in AP are constant. So let us assume Tn is a general polynomial and it is given as right. So Tn plus 1 minus Tn can be given as sorry, this will be AK only. And so on, minus of right. So each term is a polynomial of degree k, right? Because nk and nk will get cancelled and it will become a polynomial of order, polynomial of degree k minus 1. So since this had to be constant, so k must be equal to 1, so that n raised to power 0 becomes equal to 1, right? So for d to be constant, k must be equal to 1. So this proves that Tn must be of the form a n plus b, right? So we get that here Tn is given as a minus 3 n cube plus b minus 4 n square plus a plus b n minus 4. So this should be 0 and this should be 0, which gives us a is equal to 3 and b is equal to 4, right? So from here we will get Tn is equal to 7n minus 4, and T1 will be equal to, if we put 1 then we will get 3, and the difference will come out as, so this will come out as 7n plus 7 minus 4 minus 7n plus 4. So this will be equal to 7, right? So let us see. Common difference is 7 and a square plus b square was 16 plus 9 is 25. So this is wrong. Let us check d. So sum of first n will be n by 2 multiplied by 2a plus n minus 1d. Hope you all know this formula. So this will come out as 345. So option D is also correct. So the answer for second question is ABD. So now let us move on to question 3. Question 3 says that let A1 is equal to 50 and A1, A2 till AN be a sequence of numbers satisfying the rule n multiplied by AN minus AN plus 1 is equal to n cube plus n square minus AN for all n belonging to natural numbers. So which of the following is true? So they're asking for A16, A10, A11, something like that. So we must relate AN with A1, right? Because if we do it for A1, A2, A3 till 16, then it will take a lot of time. So something related to telescopic sum we have to do. But for that, both the terms should have a same format. Like here there is n and n multiplied by this also, and there is n plus 1 here, but n multiplied by this. So that is not matching the coefficient. You will understand what I'm saying. So let us start solving this. So n multiplied by, so this can be written as, if I take n here, so this will become, which will further give us, I'm taking this here, right? Taking n common here. So see here it will become n plus 1, and if I take n plus 1 here, then it will get cancelled. So that looks good. So this is looking something like telescopic series, because the coefficient here is n and there is n, and coefficient here is n plus 1 and there is n plus 1. So both the terms are in the same format, that this is the format a t by t, right? Both terms are in this format now. So I can use telescopic sum now, which is that if I take a1 by 1 minus a2 by 2 is equal to 1, and a2 by 2 is minus a3 by 3 is equal to 1, and so on till an minus 1 by n minus 1 minus an plus 1, sorry, an by an by n, this is equal to n minus 1 So cancelling out the terms, this will cancel out somewhere here and this will also get cancelled out. So we will finally get a1 minus an minus n is equal to 1 plus 2 plus so on till n minus 1, right? So from here we will get a1 minus an by n is equal to n plus 1 by 2, right? So we can now match the things. So this will give us, let us check, a16 by 16 we have to find. So an by n is finally a1 minus n minus 1 multiplied by n by 2. So a16 by 16 is equal to, a1 was given as 50, right? So 50 minus 15 multiplied by 16 by 2, 15 multiplied by 8 will be, so 0 4 120. So 50 minus 120 is minus 70. So option A is correct. Option B says that a11 is equal to minus 55. So a11 will be equal to, so this is minus 5, so this will be minus 55. So B is also correct. Now checking C. A10 will be equal to 10. So this will be equal to 50. So option C is also correct, and if you check D, then it will come out as wrong. This is a homework. So the answer for third question is ABC. Now moving on to fourth question. This is also a very nice question. So let y is equal to this long expression and we have to find out the double derivative of y at 0. So let us start solving this. Since this numerator is very long, so I am taking it as some function of x by ex. So finding out the first derivative, it will be by division rule. Also notice that the derivative of ex is ex only, so it is very easy to cancel out the terms. Sorry, this was e. We have to square the denominator also, so e raised to power 2x. So this will give ex. Further we will have right. So this will be something like this, and again we can cancel out ex and ex. So this will finally give us that double derivative of y at any point x is and since at 0 ex is equal to 1, so it will be simply equal to the numerator of previous equation. So f0 we can easily find out because this is 0, this is 0, this is also 0, and this is 0, this is 0. So f0 will be 4. And for finding, we can compute the f dash x and f double dash x only for the polynomial terms. because other terms will vanish to 0 at x is equal to 0, and their derivatives also vanish to 0 because they have high power of x. Right, because if we take derivative also, then we will be having this e sin x minus 1 raised to power 3, and we already saw that this was equal to 0 at x is equal to 0. Similarly for all these terms, so their derivative till second derivative will also be equal to 0. So f dash of x will be so f dash of x at 0 is equal to 0, and f double dash of x is equal to 6x plus 4. So f double dash of x at x is equal to 0 is 4. So y double dash 0 is equal to 4 minus 0 plus 4, which is equal to 8. So always remember, whenever the numerator is very big, then you have to take it as fx. And you can find similar problems in many test series. So hope you all learned something new from this video, and if you did, then don't forget to like, comment, subscribe, and share this videos with your fellow aspirants who will find it useful. So bye.